Then this way because the microphone. Okay. All right. So when you're doing your domain, you start at the left and you go to the right. So for your domain, you're asking yourself, how far to the left does this graph go? So how far does it go to the left? On the x-axis, -4. So your domain starts at -4. Now, does that -4 get a bracket or a parentheses? So how do we know? Let's go back to Friday. If it's an open circle, you use parentheses. If it's a filled in circle, you use a bracket. So what kind of circle do we have here? Right. So it's closed, so we're going to put a bracket. Just like that. And then, how far to the left does this graph go? So this graph goes all the way here, and there's no gaps. So notice how there's always something on my ruler. See, there's something right here. We got an open and a closed. And then right here is the end of it. So what is the largest x value? How high does it go? 4. And do I put an open or, do I put a bracket or a parentheses? Oop. Is it open or closed? Closed. So if it's closed, you use a bracket. That's it. That's your domain. Notice that we don't have any arrows. That's why we don't have a negative infinity or a positive infinity. If you have an arrow, that means it goes forever. But we don't have arrows. So we have a start and an end. Now let's do our range. So for the range, we go from the bottom to the top. Hold your pencil horizontally. How low does it go? On the y-axis, what's the lowest y value? And does that -3 get a bracket or a parentheses? Because it's closed. And then it goes up to here. Notice that we have a closed and an open. Because we have a closed, we can use a bracket. So notice how it actually hits +2. And there is a closed circle right here. So we're going to use a bracket. So our range is -3 to 2 with a bracket. All right, any questions about that? Take out your reveal book. Let's start 1-2, lesson 2. I think we're on page 13. I might be wrong. If you need a highlighter, I have highlighters. There may be highlighters on the desk. So in your reveal book, we're going to go to page 13. Really easy lesson today. Today we're talking about linear versus nonlinear and x and y intercepts. That's it. It's real simple. Okay, so a linear function, for it to be linear, you have no power other than 1. That's really the main thing to keep in mind. So on page 13, linear function, you only have the highest exponent is a 1. The other thing to keep in mind is that it is a straight line. And can you also write that it has a constant rate of change? So we're going to add that. And you can write that in the margin, or you can write it where I have it written. So linear, the word linear, what are the first 4 letters in the word linear? Line. Does everyone see that? If it's linear, it's going to be a straight line. Straight line. So that's what you need to know about linear. So if it's linear, no power other than 1, it's a straight line and a constant rate of change. And on your homework and on the test, you're going to have to look at an equation and tell me if it's linear. And you'll have to look at a graph and tell me if it's linear. Pretty basic, nothing confusing, nothing complicated. Okay, nonlinear. Well, that's kind of self-explanatory. But nonlinear, they're not going to be on one straight line. And you also have higher exponents. You have higher exponents. Okay, pretty basic, nothing confusing today. Got an easy day. So now let's look at our first couple of examples. So look at, still on page 13, look at number 1, or example 1. And I'll give you guys a minute to take your notes. Let me pause. Okay, so let's look at this first example. Even though, so we have a fraction. So whenever you see a fraction, we're just dividing. So what they did was they divided both of these terms by 3. Okay, and then 6 divided by 3 changed to a 2, and 5 over 3 cannot simplify. But when you look at your exponent, see this x right here? What is the exponent on there? It's a 1. There's an invisible 1. So because your exponent, your highest exponent is 1, and we don't have anything higher than 1, then we're going to say that this function is, that's not the right language. This function can be written in the form y equals mx plus b, so it is linear. So because we can write it in the form y equals mx plus b, our highest exponent is 1, this is a linear function. So looking at an equation, you're going to look at your exponents. If you see an exponent higher than 1, it's not linear. That means that that graph is going to have a curve in it. It's not straight. Linear functions have to be straight. Nonlinear functions have a curve. Any questions? All right, let's look at the second one. Looking at this equation, we can easily tell that this is not linear. And we know that it's not linear because of this 3. This is higher than 1. And if you were to write it the other way, you could also say 5y equals 3x cubed plus 4. So this function, the function cannot be written in the form y equals mx plus b, because it's raised to x is raised to a whole power that is greater than 1. So this is a non-linear function. All right, so again, just to recap, because we got a short lesson, if you see an exponent higher than 1, it's not linear, period. So now let's go to the next page. Let's look at some graphs. Does this look like a straight line to you, this graph? It's not a straight line. This is not a straight line. So not a straight line. This looks like a V. So this is, there is no straight line that will contain all of the points. So this graph represents a what function? A who? A nonlinear function. And that's it. Go ahead, look at the next one. This one is a straight line, right? All of these points are on one line, and it's a straight line, so this is a linear function. All right, so who's with me? Who can look at an equation or a graph and tell me if it's linear? Pretty basic, right? All right, so the second part is x-intercepts. So let's look at our x-intercepts. Got a couple definitions on page, oh, sorry, we're not there yet. Page 14, we have a word problem, and then we'll talk about x-intercepts. Okay, so for example 3, it says, Michaela has started working a part-time job at a local hardware store. Her time at work steadily increases for the first 5 weeks. The table shows her total earnings each of the weeks. Are her weekly earnings modeled by a linear or nonlinear function? So let's go ahead and graph these points to the best of our ability. So X is my weeks and Y is my earnings. So let's put our point 185. So 185 would be about here. 2, 119, that's right there. 3, 154. At 4, we're at 187. At 5, we're at 221. And I do realize that it's difficult to graph when it's not whole numbers on the actual axis. But there's another way that you can determine if it's linear by looking at the table. So go ahead and take your calculators. I want you to subtract your Y values for week 2 and week 1. So take 119 minus 85. You get 34. Now I want you to test that. So in your calculator, let's see, because this should always be 34. So take 119 plus 34. So what is 119 plus 34? Do you get 153? All right, so keep adding 34 just to make sure that it's always increasing at 34. That's why I had you write that it's a constant rate of change. If it's linear, this difference should always be the same. So if it's a word problem, you can tell based on if there's a constant rate of change. So do you think this is linear or nonlinear? Linear. This is linear. Okay, so now we're ready to talk about x and y intercepts. Okay, so x-intercepts. So what is an x-intercept? Pretty simple. An x-intercept is where it crosses the x-axis. We're on page 15. And a y-intercept is where it crosses the y-axis. Now, all functions have an x or a y-intercept. And when you look at example 4, this is my only intercept right here. So it crosses here. And does anybody remember, what do you call this place? Begins with an O. Origin. The origin, right. And anytime it crosses at the origin, our x and y intercepts are going to be the same. So this graph intersects the x-axis at 0, 0. So it has an x-intercept at 0. And it also intersects the y-axis at 0, 0. So your y-intercept is 0. So this example, both the x and y-intercepts are at the origin. Okay, but if you look at the next example, we got a lot of squiggles happening there. Okay, so let's look at this next one. So this one actually crosses the x-axis 3 times right here. Those are all x-intercepts. So my x-intercepts are at -3, -1, and 2. And when you write an x-intercept, for your x-intercept, for an x-intercept, this is something you probably want to write off in the margin. Just remember that it's always going to be a number first and then 0. Because the definition of x-intercept is x when y is 0. And when you're writing your y-intercept, it'll be a 0 first and then a number. So just something to have in the margins so you can keep that in mind. So they're writing them both as order pairs and also just as numbers. So for this graph here, it crosses or touches the x-axis 3 times. So -3, -1, 2. So my x-intercepts of -3, -1, and 2. Those are my x-intercepts. Now your y-intercepts, there's only one, and it's counting by 4s. So what would my y-intercept be? 12. So, and what I write that is 12, 0 or 0, 12? 0, 12. So 0, 12, because I have a y-intercept of 12. All right, last 2 questions. See if you can do it by yourself. At the bottom, the check. I want you to tell me, and you don't have to write it as order pairs. You can just tell me the numbers. Give me the x-intercepts and the y-intercepts for both of those graphs. Don't say the answers out loud. I am just going to peek over your shoulder to see how many of you all have them correct. Okay. So for my x-intercept, that would be right here. And what does x equal right there? Who had -5? A lot of people had it right. And then my y-intercept is right here, and that would be 2. Now for the second graph, though, we have a lot of x-intercepts. We have 1, 2, 3, 4, 5. Okay, so those 5 places, the first one is what? And next one? And so -4, -2. What's the next one? And the fourth one is what? And the last one is? All right. And what about my y-intercept? Yeah, so this point here, anytime it's at the origin, that counts as an x and a y-intercept. Okay, that's the end of the lesson. I promise I try not to keep you long. I really do. Okay, so now we're going to work on our homework. Homework 1 is due tomorrow. Who's finished with homework 1? All right, so I will be collecting that on paper tomorrow.